prefer Mac or PC?
Do I know?
Do you prefer Mac?
Well, I work during the day. I program in Windows, but I program on my Mac and also on Windows devices both. So I work in both a Mac and Windows world both. If that makes sense. So yeah, so I just have to boot up from both throughout the day. And I've done that for probably 20 years. So yeah. Prefer when as far as just if I'm not coding and I prefer a computer to do fun stuff and edit photos, probably Mac, more likely. Yeah, for sure. Yeah. I was a graphic designer for years, and so that's all we used was Macs before I got into programming. And so, yeah, that's why I kind of lean towards it, probably because of that. Yeah.
I like Macs. Became the big brother.
The big brother?
Became the big brother that they advertised.
Oh, well, yeah, there's always going to be that, I guess. But I like it's funny, I had a friend of mine that did conferences for training for Windows operating system. And he ran behind the kiosk. The Windows operating system was around that. It ran faster. The processor ran faster on Mac Mini than it did on his Intel chip.
I know a lot of programming world that I
Yeah. Uh-huh.
A lot of them buy the Mac.
Yeah.
Pro, big screen.
Yeah.
And run Windows on a virtual.
Yeah, exactly. I found I dual boot mine is what I do at home. It runs faster, natively. But yeah, the virtual works fine, like VirtualBox or something like that. VMware works perfect. Yep. Yeah, it works perfect.
Might be that. No, it is good. That's pretty much.
Yep.
Industry.
Yep. Now there is a new, but not new. It's been out a while. I think it's he's got 4 processors, maybe 6 processors. I can't remember. Maybe he's got 6 processors in it. It's Mac. It's a cylinder. Have you seen it? This Mac server, the cylinder. Yeah, those are pretty nice. But I think the bottom end on that is probably. It used to be $5,000. I think it's down to $2,800, but still. Yeah, but still, that's pretty steep for most people. Yeah, and that you never hear it advertised. I mean, you can go on the Apple Store and get it, but you don't ever hear it advertised. Let's see how much they got a quote for up here. I can look on it real quick. Yeah, Mac Pro's still selling online. Let's see what the cost is for that.
They have 4 processors.
I think it does. Yeah, I think you're right. I think it's 12. They got a 6-core and an 8-core. The 6-core is the one for $3,000. It's the low end now. The 3,000, the 6-core with 16 gig RAM. It's got 3.5 gigahertz 6-core Intel Xeon E5 processor. And then they've got a 8-core for $39.99. So if I was to buy one, which I'm not going to, but if I had the money and needed it, I would just pay an extra $1,000 for the 8-core versus 6-core. So. But yeah, I've seen them function. I've seen them in the real world scenario. They do screen pretty quick. They're pretty quick units. So, but they should be for the cost. So.
HP come up with something kind of like that.
Yeah. And I don't know if you heard I think it's the MacBook Air. Eventually, within about 5 years, all they'll be out will probably be the MacBook Air for notebooks. Form factor, and then the iMac like we use here, and then it's going to be called iMac Pro, like we use here. So it'll be the Air, which I use the Air. That's kind of I use. Then MacBook Pro, which is in front of you, and then Mac Pro. I've heard is going to even get into a higher range for commercial use, for server use. Because see, they discontinued the Mac server about, when was it? 5 years ago, 6 years ago, 7 years ago. Because UW-Madison had a special deal with Apple. They were the test bed for Apple's servers. Well, when they announced it, when Steve Jobs announced they were discontinuing the servers, they had just signed a contract with Apple like 3 years prior for a 5-year contract. So they still run all their stuff on Mac servers, because they have like a QuickTime server they use for all their campus television stuff and media. But I have heard from the grapevine they're going to come back with that Mac Pro is going to eventually become Mac Server or something like that. Mac Server Pro, something like that, which I could see the need for that. Really, what I'd like to see is a Mac Server Blade. That would be nice. No, that would be nice. See, it's for years they did have that. Businesses should buy that. Yeah.
They got the CIS.
No. Yeah, Dell's got the market now on that. Yeah. And Sand's real big right now. So yeah, I mean they're just not in that market. So, but I could see them bumping up the Pro into a bigger commercial market for servers. Really be nice to have it for cloud-based type stuff, I think. Cloud media, streaming media, maybe. Could they do well in that?
Well, I like the fact that Unix machine.
Yeah, Unix-based, yep. Yeah. And it's, you don't. I don't have antivirus on my Macs, to tell you the truth, and none of the work ones do I have either. So you don't need it. So
There are some viruses on it.
Yeah, no, the virtual machines do have the virtual PC machines do have it, but Mac itself doesn't.
Professor, one of my laptops, they completely wiped out Windows, and I put
Ubuntu, Ubuntu is nice. That's a nice
I
OS.
still have the CPU.
I like Ubuntu, yeah.
But there's no.
Yeah. Yeah, they actually have a version of Ubuntu now on the cloud that I've played with a little bit, which is pretty cool. You can test it out. It doesn't cost anything, and it's a fully fledged operating system in the cloud, which I could see Chromebook using that maybe one day. Chromebook's using that probably.
They're based on.
Yeah, it is. Yeah, I can see it all being in the cloud though. I don't see why not. Why they shouldn't do it. Adobe's all in the cloud now, so a lot of your big companies are not pushing everything in the cloud anyway, app wise. So everything's going to the app cloud and OS cloud.
It's hard when you get in.
Do I know?
It's hard when you go like where I'm at, pricing
Right.
everything, and they got a lot of iPads. Got the HP.
Yeah, we got work. We're getting rid of. They had a whole bunch of Surface Pro for the sales guide. There was too many errors we're getting on charging, on syncing, and so they're looking at a Dell model. It's a Dell. It looks pretty nice too. It's much less. Well, about $400 less price point than the Surface Pro, but much more solid. I think it'll be much more solid. I don't think the Surface Pros are ready for market personally. I just don't. I think they pushed too quick.
Price looks like.
HP's always been a good product. I think there's nothing wrong with HP.
And it's a nice tab.
Yeah, and they're solid too. Yeah, they're very solid. Because HP, I don't know if they used to be able to give and Dell would get this for 5. You can get a 5-year on HPs. You used to be able to. Because Dell's you can get 5-year too on the new tablets, which that's nice for businesses. Yeah. Because I think at Aqua they do I think it's a 3-year minimum, 5-year is what the average is though for our sales guys. Depending on how hard they are on them, they can do it within 3 if they have to.
I think we're 3.
Yeah, most are 3-year. Even though ours are max 5, most do turn over theirs in 3.
Yeah, then sell them to some company called Play It Again PC.
Oh, really?
They're out of Michigan. And they did a lot of the off-lease
Oh, really?
machine.
So, would you mind sending me that link? Because I know they were asking me about something a while back on it. So they do a lot of recycling on theirs, and then they also get bids the employees to come and buy them and all that, or give them away.
Yeah,
But if you send me the link, yeah, I might look that company up.
I'll Play It Again PC.
Play It Again PC. Okay.
I'll see if I can find one.
Yeah, that'd be great. Oh my God. Starting off good. Big Bertha. I like it. Good. Cool. All right. As soon as you get checked in, go ahead and go on to the Kahoot up there on the overhead, and we'll get started when everybody gets joined in. It's going over classes, which you went over this week using Solo Learn. Some creative names tonight. You guys want to? Yes. Do I know? The QR. Do you have a phone? You can pull it up from your phone. If you want to come up here, I can pull it up for you. Okay, what's your S number?
S04929.
0492911.
Mhm.
Right. It is. I'll just send it to you if you want. That way you can have it from now on. All right, you put your phone number in there. Okay. So make sure you get it. And then you can save it to your phone and check it up here. Six, 8, 9, 10, 11, 12. Okay, should have 13. Six, 8, 9, 10, 11, 12. Yeah, 13. So 13, when we get to that number, we'll get started on it. Joining Dilly Dally, Reading is Hard, Temp, Hot Dog, Speedy, Buddy, Swim, Root, Squirrel, Wild, and Big Bertha. One more. There we go. Here we go. Classes over what you went over in Soul Learn. Object-oriented programming is closer to thinking about the blank world. The blank world. Whole world, real world, round world. Real world. Hence, object-oriented programming, relating the real world scenarios into a class, which we'll talk about this week. So there's our leaderboard. Objects can have blank attributes. The mug can be empty, red, and large. Multiple, 3, 2, 4. Okay. Multiple can have multiple attributes in an object. Leaderboard. 3 dimensions describe object-oriented programming, identity, attributes, behavior. True or false? The answer is true. Leaderboard. And programming an object is self-contained with its own blank. Mind, identity, artificial intelligence. Identity is the answer. Leaderboard, class blank or special member functions of a class. Class functions, class variables, class constructors. Class constructors are special member functions of a class. Each class has a name that describes attributes and behavior. Right. Leaderboard. A method is basically a blank that belongs to a class. Variable, function, destructor. Function is correct. Moving around on leaderboard there. This class specifies each object should have the defined attributes and behavior or blank. Definition, pointer, value. definition is the answer. Begin your class definition with the keyword what? Blank. Class or class? Cap C, lowercase c. It is lowercase c. Reading hard, streaking ahead with 4 in a row. Define all attributes of behavior or members in the body of a class within brackets. Is within the left and right parentheses of the bracket, not brackets. All right. Good. Good job. First thing we're going to go over is this week is, by the way, we're covering bitwise logic and beginning of classes. Next week is structures, then classes in week 8, 9 pointers, and 10. We'll probably be spending time in 9 and 10 both in pointers, even though 9 says more class, we'll be doing class starting out in pointers at 9. Reading and writing files in week 11, debugging in week 12. Begin working on your final app full time, even though you can start working on it now for sure. All of week 13, when you come into class that night, I'll be here and you can work on your app. You can work on it from home if you want to. I will be here as a resource, so the entire time on week 13. Week 14, same deal. I'll be here as a resource. So what I suggest is even now, when you start creating your skeleton for your app, you probably know you're going to need help in some areas maybe. Just shoot me an email on what you need help with, and I can give you some code snippets and some resources and references to help you to get the foundation laid. Does that make sense? That way you don't wait till the last couple of weeks. You kind of have ahead of time what you think you might need to need help with. And the easy way to do it is look over our class structure and what we're going to be going over. You can go inside of each one of the weeks. If we're not going to cover whatever you need help with, we're not going to cover it enough, let me know, and I can give you examples and help you out. Okay? So don't limit it to only what we're covering in the class. If you need more help beyond that. I also want to mention week 6, I will be probably it'll be after spring break. Yeah, probably after spring break. 2 weeks after spring break, on those 2 Saturdays after spring break, I'll be opening up those 2 Saturdays, and I'll send out an official date from like 10 to noon for those of you that want to do a GUI-based C++ application. Maybe you're not going to use one for your final app, but you kind of still want to know how to do it. Those 2 Saturdays and after spring break will be allotted to help you get started in that if you want to learn how to do that. Yes. I haven't given an official Saturday, but I know it'll be after spring break. So I don't know if I'll do them back to back. It depends upon really the need from you guys on what you say you want help with. So if I get, say, 5 show up on, I'll give a list of dates, a list of Saturdays, and whoever I have the most show up on or say they can show up on, that will be the 2 Saturdays I'll choose probably. Good question. And so a few of you have asked about that, even though you might not be using it. You might be doing console-based for your final, but you still kind of want some tools to help. One Saturday will be over C++, Objective C++, GUI based. The other will be over game development using game engines in C++. And I think I put in here in the modules for the final help resources, Godot uses the C++ code for the actual base of the game engine for 2D game creation. In high school, I used to teach C++ and intermediate C++. And back then, the big game was Counter-Strike. Anybody remember that game? So the deal was I would do a LAN party if students created 4 levels, or maps is what they call it in Counter-Strike. 4 maps, had to be complete maps, created on their own, couldn't copy code from the web. Once they all created the 4 maps, then I would open up a Saturday and we'd do a LAN party, and I'd buy pizza, and they'd play their maps basically in the LAN party. And this was back in early 2000s, and these were like 10, 11, 12th grade students that took the basic C++, like you guys have already taken, take some intermediate. But in that intermediate, they would also, last half of the semester, just do all mapping in Counter-Strike. That's all they did. And so, but, Counter-Strike gave you a really cool game engine to work with to implement your C++ code. And so, and a lot of tools to help you with it as well. A lot of games still do that today, by the way, in Steam, which I believe is what most first-person shooter games are running on now. All these games have generally have some type of open source compiler, or you can find them, by the way, and make your own versions and things of that nature. That's also a fun way to learn programming as well. So, okay, so tonight we're going to first of all get into kind of go over some of the solo learn stuff before we get into the stuff for this week, which are some examples I've got to look at. I'm going to open that up right now. So first thing is we're going to go over the first 3 of these tonight. Just kind of some notes. I think the notes on this one for solo learn, they're all good, but I like how they introduce classes and objects. And so starts out right with the beginning, which what is an object? So object-oriented language, which C++ is, C# is, modern day Visual Basic is now, F# as well, which you might not have heard of. It's also a popular one. There's object-oriented, PHP, object-oriented web language. And so it's basically a programming style that is intended to make thinking about programming closer to real world. So from this week on, we'll start getting into more advanced topics with C++. And you need a good understanding of classes. That's why we're going to spend a couple weeks on classes, because before we get into pointers, most books have pointers before classes. I like to teach classes before pointers because pointers are more confusing to students if they don't understand classes first. I found out over the years. I don't know why books always put it that way, but that's the way it is. Even though in your solo learn, you've already went over some pointer stuff already. We'll go more into depth on pointers, which really pointers and coupled with classes is where the power of object-oriented programming comes in. And so programming objects are independent units, it says, each of its own identity, and just as objects in the real world. So an apple could be an object, a mug could be an object, each have its own unique identity. Possible to have 2 mugs look identical, but they could still be separate, unique objects, maybe with a different logo on each mug, a different size of the mug, just to give an example. Objects also contain other objects, but they might be different objects within those objects, and they have what's called characteristics. Objects have characteristics that are used to describe them. For example, a car can be red or blue, a mug can be full or empty, or have a logo or not have a logo, so on and so forth. And up to this point in programming, you've done a lot in the intro C++, and a lot of it has been repetition of functions over and over again. Class is bringing a whole new realm now to programming where the true object-oriented programming takes place now. So objects can have multiple attributes, like a mug could be empty, it could be red, it could be large, it could have an icon or a logo or not have a logo. But what's cool about objects is the state of an object is independent of its type. So a cup might be full of water, another might be empty, another might have a logo, another might have, be tall, be short, whatever the case may be, different dimensions, all have a different state within its type. In real world, objects behave in its own way. The car moves, the phone rings, so on and so forth. And the following 3 dimensions describe object-oriented programming. identity. An object has an identity, has attributes and behaviors. And what's cool about it is those identity objects, attributes and behaviors can be used in different ways in your programming in one class, to where you're encapsulating the power of a class in hundreds of different ways with one unique class versus a function for each one of those, what we've done at this point. So in programming, an object can be is self-contained with its own identity, kind of like the screenshot here. The object has its own attributes, which can describe its current state, each exhibiting its own behavior. So you can have a person, two-person objects here, and a car object. Person object, you have John, age 25, talk. Amy, age 22, can talk. Car is red, year 2015, can start, stop, and have a horn function in there as well. And these, by the way, are representing functions within the class, like it was in your quiz tonight, and it was also in your reading and solo learn. And you can call these functions independently of each function within the class. And it doesn't, each function that you call is separate from other functions within that class. And it doesn't hurt that function or impede that function whatsoever, which is kind of cool when it comes to classes. So objects are created using classes, which are actually the focal point of object-oriented programming. The class describes what the object will be, but is separate from the object itself. In other words, a class can be described as an object blueprint of it, like a house or a car's diagram of how to build a car, how to build a train. But it also has within that blueprint the description and definition of each and every object within that build. You can use the same class as a blueprint for creating multiple different objects. For example, you can create a new building. The new architecture creates a blueprint, which is a basis for a foundation. The same blueprint can be used multiple buildings in iterations, which architectures do that. So do programmers. We create a class that can be used in hundreds of applications, right? A class can be used for, say, a class for calendar or calendars, a class for grades, a class for calculations, a class for you name it, can be created. And that class can have sub-functions that can do multiple different powerful things that can be called throughout your application in a public way. It can also be called, you'll learn, in a private way as well within the function, within the class. So each class has a name, and we already learned it has to start with a lowercase c, class. It also describes the attributes and behavior within that class. So in programming, the term type is used to refer to a class name. We're creating an object of a particular type. Attributes are basically the properties and the data of that type. So method is another thing within the class behavior that is basically a function. So a method is basically a function within a class. It can be called publicly. It can also be called privately within a class. We'll learn tonight, we'll play with tonight and this week, a public function, which is the best way to start out anyway. And methods are similar to functions in the fact that these codes can be called, these blocks of codes can be called in multiple ways throughout your app and return different values. So a class example would be like a banking program it gives in Solo Learn, which is a good one. So you got the name of the class, bank account, the attributes, which would be your variables, account number, balance, date opened, and then the behaviors would be the functions, open, close, deposit. Sounds pretty simple, right? So the class specifies each object, how they should be defined. However, it doesn't exactly specify what the data is, and we really at this point don't care what the data is. We're just creating a class to do certain functions right now. And that's called a prototype, a class prototype. And as a programmer, what we do, once we create a class prototype, that's when we go in and uniquely define and spend time on what's the inner workings of open, what's the inner workings of closing, what's the inner workings of deposit that we want to use within our application. And if we want something different but close to one of these behaviors or functions, we just copy it, paste it, rename it, and add whatever it is we need that behavior to do. That makes sense? And so you can call it multiple times, create a class once, call those multiple functions, and copy them. A lot of times I'll do to tweak it or morph it to do just a little bit more than the other one's doing, or even a little bit less than the other one's doing, without having to reinvent a class or recall another class or recreate another class. So once we've written a class, we can move on to creating objects. And basically, when you create a class, what I always tell students is when you're creating a class, and that's why I like solo learn, come up with the name of the class as being the main objective of what this class is going to do, okay, first. Then you think about, okay, within that objective, what are some sub-objectives that I can glean from this global class, right, that I can call within this class. And don't worry about what that method or function is going to do yet, just create it. Because if you spend time on the reverse logic of, which I've done before, of spending a lot of time on creating the methods within a class, it bogs down that process, if that makes sense, creatively wise anyway. Programmatically wise, no, it doesn't, but creatively it does. Because you already know, you've been in programming long enough now to know that when you get into a function or a piece of code that you're working on, you become isolated to that code you're working on. You're not real creative at that point. You're just wanting to get the code to work, right? And so you're doing a lot of iterations and debugging to get that code to work, right? You're not thinking up high level right now. You're down in the muck and mire of that code. And so I always tell students to put some time into this first when you're creating your classes and your methods within your classes. And you can always flesh out the behaviors later. That makes sense? Kind of like an outline of a research paper, which I know many of you love to do. So, English teachers always tell us to do what when we create a paper? We had this in, grade school, high school, whatever, right? First thing, turn in what? So I can look at it. Your outline. Your outline is basically what I'm talking about with the class prototype. What your outline is going to determine the success or failure. And failure is a bad word, maybe just a longevity of how long it's going to take to complete that class. By creating a good outline, it's going to help you. So let's go to the next one. Example of a class we're going to end on. Then we're going to do some examples, some real world examples here in a second. So to begin your class definition, begin with the word class, followed by the keyword, class name, the body of it, which is going to be in the curly brackets here. And then the code in this case is going to be, the class is called bank account, and it's different than up to this point because it's followed by a class is followed by a semicolon, unlike a function, a self-contained function. And so it is its own entity within your CPP file, basically, at this point. When the compiler sees it, when it sees that semicolon, it notes, okay, this is something different from the main. This is outside the main. It's outside the scope of the main, basically. So defining or declaring a class, when you're defining all the attributes of behavior in the body of the class with curly brackets, define the access specifier, which will be your variables of the class. And then from that, you're going to decide, okay, is it going to be public or private? Meaning if it's public, it can be accessed outside of that class. If it's private, it can only be accessed within that class. Okay, and we'll learn more about that in the coming weeks on private. But just note that your class can be members can either be private or public within that. Private would be protected, meaning it cannot be accessed or used at all outside that class. The same as functions that you've done up to this point have served. If you did a private function within with a private variable within a function, it can only be used within that scope of that function. If you wanted that variable to use outside of that function, where would you have to declare that variable? What would be if you wanted to use a variable that's global and with all your functions up to this point, where would you declare a variable in your code? What's a good place to put it? Where at?
Outside of the main.
Yeah, outside the main, right at the top, maybe underneath your using standard line or something, declare your integers, your doubles, your floats, whatever. And those are going to be global. It's where you can use a counter of some type or username or whatever it is you're using. So again, we'll talk about that later as far as the private stuff, but just know you can have public private. This week we'll focus on public only. So when you're creating a class with one public method, it says here, this one's going to just print out hi, basically, is all it's going to do. The class is named bank account. It's a public class. Here is the method within the class or the function. Might be better understood by you maybe to just look at it as a function within a class, which in essence, that's what it is. So all it's doing here is doing a cout hi. So the next step is within the main, you'll notice, use the name of the class, space, and then whatever you want to call it. And now it's going to be initialized as that class. So in this case, test is now going to be, and it is, class, calling the class and all of the attributes and members and data and calculations or whatever's in there is going to be part of that word test now. The next line, test.sayHi, it's actually going to that class method and calling the sayHi to print out hi. So object named test, all of its members, properties of that class are now part of test. Notice a dot operator. This is used to access and call the method. And so unlike variables that you've done up to this point, but kind of like variables because it is a type of something. And instead of being an integer or a double or a float, it's a class. You're defining it as. And it's a user-defined class. You define this class. C++ did not define this class. It's user-defined. And again, that's where the power of object-oriented programming comes in because you yourself define the classes that you want to use. You don't have, C++ does not define them for you. Up to this point in programming, you've used the defined functions or defined methods that C++ has given us. Now with classes and pointers, you start defining your own methods and procedures to use. Let's see. Yep. Okay, so now what I want us to do is go to, and you might need to refresh your page because I just published this recently. I thought I published it earlier. In week 6, there's a link called examples. It's at the bottom under discussions. There's a book I put in here I really like, and I've used it for a number of, probably about a year and a half, 2 years now, to show people different codes and snippets and data and learning C++. It's actually it's called a GitHub book, which you can create. It's called GitHub book is the name of the publishing. And so if I click on this, I'll just show you. I have it pointed right to log in here. Get rid of that, by the way. When you click on this, looks like I had it clean. I had index.html on the end of it. Get rid of the index.html and it should work for you. I'll correct that now while you're doing that. Okay, so as soon as it comes to you get rid of the index.html and hit enter or return, you'll notice on the left side, it's got the index of the book, but all the way at the bottom left, see where it says published using GetBook? If you click on that published using GetBook, and any of you that are interested in this, by the way, I've done some publishing over the years for students in my classes. GitHub has a thing called GetBook, which basically allows you to teams or teachers or anybody, students like yourself, you can create and collaborate content online and sign up. And there's not a lot of people using it right now. It's pretty unknown. And so, but it does work really well. And they do have pricing in it for open source right now, which is unlimited public books, which I recommend you do. So if you wanted to create a little booklet or say you, in your final app, you really learned a lot of cool stuff on whatever it is your app's going to be. Let's say it's you figured out an algorithm to search for images of dogs or something, all breeds of dogs within 5 seconds or something like that. I don't know. Just thinking out loud. You figured out how to do it. You're going to create a little booklet to show people how you did it. you can use this to show people your steps of how you did it. So it's free for unlimited public books, unlimited visits and updates. You can have 5 other people help you with the book. Also has custom domains built into it, and it's totally free. So, hey, why not, right? If you know companies, which I have a company I work with that's doing one for their business where they're creating booklets and of training material, they're doing the more the business side, which is $249 a month. But again, it's for businesses only. You guys can focus totally on this open source one, which will be fine for what you're going to need it for. Anyway, this Earl Robotics, basically this book was written as a tutorial for C++ for a small, Earl Brain is a small size Linux computer for making drones. Okay, that's how it started out. So it was a project, right? It was a project to create, using C++ to create a brain for drones, basically. And it actually gives a picture here of the project, of the actual brain here. It says here is inspired by the BeagleBone development board. We designed a small computer with about 36 plus sensors, a lot of I/O and processing power, real-time analysis. Earl is enabling technology for next generation aerial terrestrial robots and used in cities, solving tasks such as surveillance, environmental monitoring, and even providing aid and catastrophes. It's a small size Linux robot or computer bringing robotics to people and businesses. Now, the reason I stumbled upon this, I do drone. I'm a hobbyist drone person. I do a lot of flying in multiple different drones I have. But I also do, like to program as much as I can those drones. And this was a really good find that I found a while back. So anyway, he gives a really good, and I put the link, by the way, in this one so we could look at the classes when he gets down to the after pointers. Just like most books, he does classes after pointers. But I want to kind of just go over this roughly, just kind of an overview for you to spend more time in this book, because it's a really good reference book. And you know me by now, I love giving you guys as many references as I can, because it definitely does help you, I believe. Helps me as a programmer, hopefully helps you as a student as well. Because people explain things differently and show examples differently than other people. So anytime I find something like this, I'll show it to you guys. So anyway, he starts out with talking about classes and structs. I won't go into this, read it, but he gives a really different example, different way of looking at classes, and you're probably already guessing it has to do with math because of the robotic calculations you had to do with drone technology, which again is something different, a different way to look at classes. But he even brings into it, the reason I like it is he brings into the class realm structs and class all at the same time, which I think is important. And so I just want to throw it out there for you to look at it, look at all the examples. You can compile these in your Replit and play with them. And so again, it's just to kind of throw it out there for you. To definitely bookmark it. It's a great reference, by the way. And I didn't show it to you earlier because I didn't want to confuse you. So now you're ready for it. So it's a great book. Anyway, this next one is one I want us to look at. This example here on Solo Learn Play C++. Or no, sorry, that's not the one. Back in the modules for week 6. The assignment, I believe, is where I put it at. Yeah, 6th assignment. 6th assignment, we're going to look at 3 examples of classes: an abstract class, a practical, a normal class, and then we're going to look at the declare and use classes one at the end, and I'll have you modify that last one. Okay, the first 2 we're just going to look at and play with it, go over the code. The last one we're going to look at it, but I'm going to have you add some stuff to it like I normally do for the in class. And so let's go ahead and click on the first one, which is the C abstract classes. So this one talks about abstract methods, indicating basically that an abstract method is a method that is declared but contains no implementation. And that's what the term abstract means. It's just kind of out there. Abstract classes may not be initiated and require subclasses to provide implementation for the abstract method. The way this concept is expressed in C++ is to have the member function declared assigned to 0. And so basically by doing that, you're allowed to call it throughout your code as an abstract class. So here you'll notice on line 14 through line 25, there's a class called A, okay? The A class is public on line 15. Inside of that, underneath that, you have a virtual function called virtual int f. And notice it does this right here. It does a cout a.f x. If x is equal to 0, return g. Else return f x minus 1. All right. You'll notice if you go down to the next line, 24, g is the abstract in this function, which we'll see how it works in just a second. And notice it's initialized, and the comment above says at 0 to where we can utilize it. Next, the class B. Notice it is referencing the public A, and it's public. And inside of class B, int G override, and yes, it's calling that abstract. And in the cout, it's calling b.g, and that's it. Now let's look at the main, what it's doing. In the main, it's declaring B is new, meaning it's reinitializing it, and it's pointing it to the F for 3 times, going to F 3 times, meaning 0, 1, 2, 3 is what we should get here. It's going to call it 3 times. And so once it calls it 3 times, we should get the X here at 0 on line 17. It's going to go down to the line 18. Is X equal to 0? No. So it's going to go to return F, which is back to, it's basically on line 21 going back to the function again. Denoting it 1, going down 1. So it's going to start with 3, then 2, then 1, then 0. Once it gets to 0, then it goes to return G. Here's where it goes to the abstract. And then notice the override statement in this public class B is where this will finally be kicked out, which should be b.g, should be what it ends with. So let's go ahead and run it and see what happens. So a.f 3, like I said earlier, then 2, then 1, then 0. Gets to 0, it goes to the public class B, which is a reference to public class A, and that abstract. All right. Now, abstract can be confusing, and I know it can be confusing when you first look at it. But the reason I want to show you abstract is just play with it, look at it. I don't want you to change anything on it. Okay. Well, I take it back. You can change some stuff on it to see what it does. Maybe a way to play with it, create more abstracts within virtual int f, stuff like that. Maybe play around with some more of the calls instead of 3, maybe changing that number to something like 6 or 5 or 4 or 2 or something like that. But that's about all I want you to change right now, because in a couple of weeks we're going to hit back on abstract again and come back to it, circle roundabout. But that's a C++ abstract class. Next, I want to look at the second one, which is the C++ practice classes in 6th assignment. This one uses a class called animal. And notice in the class, it has both a protected integer called legs. In the public sector, it has animal, which is calling here, hello, I am an animal. Cout, constructor of an animal. And then void say hello. It also has a, on 16 through 18, function that's calling the void animal. And notice it's calling the say hello with this line here, 2: say hello. And then it's finally got another class called dog. So 2 classes in here. One is animal, one is dog. Inside the dog, it's a public all, and it just says constructor of dog on the C out for that one. This one here, 16, is actually a function that is also initiated part of a class. Let's see what happens in the main. So as we've already went over earlier, you'll notice on line 29, animal, which is a class, space animal. Now animal is now having all the methods and procedures of the animal class, which it's available to this class is going to be everything under the public. Okay. Next, animal.sayHello. It's going to go to the animal class and go to the say hello function, which is going to basically just go down here and say, hello, I am an animal. Then dog, another class initialized here, dog.sayHello. And you'll notice on this one right here, dog.sayHello, in here there is no say hello, but you'll notice the class dog also is now a part of the public class animal as well. So let's run it and see what happens. So a lot of calls, a lot of classes called from other classes, which you can do. And again, it can be confusing, but I try to make, a short snippet here. We're not going to change this one as well. You'll notice the very first line, constructor of an animal, which is this call right here. All right. And because you'll notice in line 30, animal.sayHello. All right. Constructor of an animal. Kick that out first. Then it went to say hello, which says, hello, I am an animal on line 17. Then next, animal.sayHello. What's hello, I am an animal. Constructor of an animal, because it is part of the animal subclass. And then lastly, the dog.sayHello. Hello, I am a constructor of a dog, and hello, I am an animal. So on this one right here, the dog.sayHello, remember it is from this one right here. But because it's this class is also calling the class animal, it's going to kick out the constructor of a dog first. Then it's going to kick out the say hello second, which is going to kick out the hello, I am animal. All right. It can be kind of confusing. Again, look at both the abstract and this one both. Next couple of weeks, we'll come back. We'll circle around both of these. Because tonight we're going to focus, this week we're only focused on the public class stuff. But I wanted to throw these at you just to kind of mull in your head. Now I want to go to the last one, which is declare and use classes. The more simplistic one I want to play with tonight. This one is calling or creating a class called add. And right now in the class, all I have, it's public. I have 2 variables, x and y as an integer. I have an integer sum method, and it's returning x plus y. Okay. In the main, I have initialized calc as a class, the add class called calc. And then in 26, I have enter number 1. Now I'm using calc.x, which is public, so I can do that. So whatever the enter is going to go into the x variable for the calc method, or the class method. Class variable, I'm sorry. Then enter number 2, calc.y, goes to the y variable in the add class. Then finally, see now the sum is calc.sum. And you'll notice in the calc.sum, it's going to return the values of x plus y. So let's go and run that. You'll have to enter in number 1. I'm going to go ahead and enter in 30. Return. And I will enter in 10 for number 2. and that's what you should get as well. So what I want you to do the next few minutes is on line 13, 16, and 18, and then also on line 31, 33, and 30, 31, 33, 35, I have some comments for you to fill out below that comment line, some code. First is on line 13, create an int mult that returns multiplication of x and y. Then line 16, create an int method called subtr that returns subtraction. Then lastly, create an int div method that returns division. Then back in the main, you'll need to create couts for all those. So create a cout for calc.multi, calc.subtract, calc.div. And then when you run the app, enter in 30 for your first variable, integer, and 10 for the second, and see what happens. Okay, and I'll pause mine here, and I'll come around and give you a few moments to do that. Then I'll come around and walk around, see if you need help. Then I'll show the answer on the overhead here in a second. And again, you can reuse, like I talked about earlier at the first of class, when a function doesn't quite do what you want it to, or a method doesn't quite do what you want it to in a class, you can copy it, repurpose it, rename it to your purpose that you need it for. And that's all you're going to have to do. You can keep all the methods integers as well for our case that we're doing tonight. And I noticed on the 38 on the comment, the 37 comment, I put an I on multi. It should be just mult, M-U-L-T, instead of multi. It should be CILC dot M-U-L-T, not M-U-L-T-I. So we're using that same class, everybody. That's the class add. Basically, just copying the method, which is called sum right now, which is 10 through 12. Well, pasting it 3 times and renaming it. So that's good. Song is subtraction. Yep. Inside the public, yes, correct. Yep. Yeah. We'll do that next week. So, cool. All right, well, let's see what got here. You guys are all looking good on that. Okay, so yeah. New is going to actually reinitialize the class altogether. It's like a kind of a whole new class. We'll cover that also. Question. Okay, so what I did on mine was, you could have done it differently, a little different if you wanted to on the verbiage and stuff, but we kept the class as is, which is add, and then just copy and pasted sum on 10 through 12, copy pasted that, and 14 through 16, 19 through 21, and 23 through 25. Rename the method to what we wanted it to be, multiplication, subtraction, division. Also changing the calculation to what it needs to be as well for that method. And then within the main, copied line 26 or 36, and then pasted it on 38, 40, 42, and renamed your method to what it needed to be from the class. Reword the verbiage here. So I entered in 30, 10, sum value is 40, calculated value 300, subtracted value is 20, and the divided value is 3. And so you can see by just changing the, or adding to our class, the methods that we need, we can call this throughout the application and use it in multiple different ways. Much like a function, but it's basically being called within one class and self-contained within that class. That can be called multiple times. So, everybody get that? So classes are definitely powerful. First lesson in classes, in class anyway. Understanding classes, especially abstract classes, can be confusing. So I kind of gave you those first two tonight to kind of look at and play with, kind of wrap your head around it, go in there, go in the code and tweak it and rework it. The best way to do it and to play with it. Just like anything in code, when you play with it more and more, you'll understand it more as you're playing with it, as you're coding different things in it. And you can always go back to my original one if you screw yours up, which you will, and then you can restart over again. That's okay. That's good. It's good to do that. One of the things I always tell people when I'm in programming a project and they're getting ready to test it, I always tell them, I say, see if you can break it. See if you can break it. And testers generally can break it pretty quick, like within a few seconds. Even something you've worked on for a long time, a tester can break. And this is when I'm talking about testers, a non-programmer that's testing your application you're creating for them. An example I'll give you is the final app you're getting ready to do for the class. I know you're going to spend a lot of time on it. You'll fine-tune it to the best you can, but you'll give it to somebody to play it and say, okay, I'm not going to tell you anything. Just see if you can, get the app to do what it's supposed to do. They'll break in about 2 seconds. Okay. What'd you enter in? Well, I right-clicked here, left-clicked here, I entered this file. What'd you do that for? So again, it's good for us programmers though, because sometimes we think analytically, but we don't think sometimes as the end user is going to think on how the app's going to work. So anyway, break the classes and subclasses and the abstract class. You can definitely do that. Now I want to go back to the final app, basically, for the assignment is kind of a build upon the last one we did, the declare and use. And so let me go into that real quick. Log in. Let me go use my Rock Valley College email for that one. Not. Spelled that right. I don't want to do it wrong. Let's see. Let me go back to my tablet here and see if I can pull it up that way. I don't want to lock it out because I know I'm going to do it if I go one more time. There we go. Now I'm pulling this up on my laptop, on my tablet, so you're not going to see it on the overhead. But if you want to log in on your end and your replit, that's fine. Okay. So lesson 6 classes. All right, so this one is writing a class named rectangle, having 2 private variables and 1 member function, which returns the area of the rectangle. Declare variable as rectangle to the length, should be the length, the breadth, the length and the breadth of the rectangle, and then returning the area. CN is what it should be on that on Cindy. And so use and declare a class to do that. The example that I give you is the example we use for the declare and use class in the classroom. And where it says here on the having two private variables, one member function, yada, 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 the private variables are going to be private to that function, but they can be called, I want you to declare that class as a public class, the entire rectangle class as a public class, just like the one we did here. So disregard the private function or the private variables. I will rename that right now. I don't want it to be private. I'm just going to put two variables. I'll rename it to two variables is fine. For some reason, it says Cindy in here instead. C in length. There we go. Okay, I saved it. All right, so basically just like this, but you're going to be using, instead of the add function or the add class, it's going to be called rectangle. And it's going to have two variables in there to bring in and do the calculation for return for an area. And so you can determine what you want to call that method, but it's going to come back, it's going to come off from the main. So it's going to need a length, a breadth, and then a return cout for the area. Okay. As far as challenge on this one, again, if you want to add more to the functionality of it, as always, make sure note in the submission here what you've done for extra credit, which some of you have been taking. I know you don't get 5 or 10 points, but it's just something extra that you want to do. That's fine. Questions on your assignment? Okay, let's go on to the next one. Review questions. Oh, and by the way, make sure to do your review questions. And I wanted to show you inside the course conference at the very bottom, the solutions code. Right now through week 4, week 5 will be posting here by Wednesday. When you click on each one of these, it's going to bring you to the source code for each one of those weeks. It could be something you could look at to compare to your code possibly. Questiones. Now here's a little heads up. If you haven't yet started on your foundation for your final app, I would suggest doing that. If nothing else, in Replit, just creating the comments at the top, then you start putting in that comments, the thought behind the application. At least do that. That way you've got a point somewhere where you can say, okay, I've started it mentally. I started that. What you don't want to do is wait until after spring break before you start that, because you come back from spring break, been at college long enough to know. After spring break, the mentality of projects goes, you haven't started yet. Okay. So if you start them now, at least it'll be a trigger to you to kind of, on a Saturday when you got a free hour or two, you can go back in and start working on it. And I recommend to students, if you have, I always do, like for my own personal projects, I have like a time through the week. Usually it's on a weekend where I spend 2 to 3 hours. It's usually early morning on personal projects, the projects I'm working on. That would be what I would do with your time. Carve out some, whether it be early, late, whatever your best time working is, and just each week spend that amount of time on just the final app. Sometimes you might spend 3 hours just looking at code, looking at examples, researching, right? Finding out what other apps are doing to kind of help you in the idea of the app that you want to do. Make sense? And then finally, by the time after spring break gets here, when we start rolling out, crunch time for the app, you'll have a good head start. Does that make sense? So just don't wait till the last minute. Questions on that? Okay, well, that's all I got. If you have any questions, come see me. Otherwise, see you next week. Come up and ask a question if you haven't. Yep. What you need?
He wasn't here, so
Okay.
a little bit.
Yeah, if you want to come over here, I can show you real quick. On the final app, let me turn off the recording here real quick.